Inflammation is a good place for us to start because, number one, we're all super familiar with inflammatory responses. Number two, it's very generalized. You can have an inflammatory response to lots of different things. And number three, we've already talked about all of the main mechanisms that we'll introduce here. So it's kind of a neat and interesting conversation. So the inflammatory response is caused by chemicals. So if you want to have an inflammatory response, you have to produce inflammatory cytokines. And the term cytokine is kind of an odd one. It's reserved usually, it's a chemical, and it's reserved to describe immune stuff, but it's usually secreted into surrounding tissues. So I would argue that most cytokines are paracrine molecules. It's usually a local response, although you can secrete cytokines into the blood. They're kind of this weird immune-related thing that the term cytokine itself is not hugely beneficial. But when I refer to cytokines, which we will refer to them often, just know that they're a chemical associated with the immune response. So there's a couple of times when we might produce these inflammatory cytokines. So like what causes us to produce these? Tissue damage can lead to the release of inflammatory cytokines, often by the cells that were damaged. And where have we seen something similar? When we broke blood vessels in the last lecture and talked about the process of hemostasis, the broken blood vessels are experiencing tissue damage, and they probably are producing inflammatory cytokines as well as all their other chemicals to stop the bleeding. Tissue damage can lead to inflammatory cytokines, but so can pathogens or invaders, anything that's going to cause some kind of a disease, a bad guy. And why are we going to have an inflammatory response? The purpose, inflammation actually creates a barrier. You can imagine, like if you get a splinter, you actually have an inflammatory response to the splinter, and it kind of creates a barrier between the splinter and the rest of your body, and that can prevent the spread of bad guys. It also brings in white blood cells, and white blood cells we will see are the main army people, the doers of the immune system. And then the inflammatory response promotes healing. So the chemicals that are released and that are part of this help initiate the healing process from some sort of invasion. So when you think of inflammation, you probably already think of 4 signs of inflammation. 1, what do you think of? Redness, right? 2, heat. I have to tell you right now, this is not fever. Fever is something else. In fact, check it out. Fever, we're going to talk about fever in its own category. Redness, heat, swelling, and pain. These are the 4 signs that you're having an inflammatory response. And the cool thing is that there are 2 what? There are 2 mechanisms that inflammatory cytokines initiate that bring about all four of those, what, signs. So let's talk about redness and heat first. Think about what you might do. What if you wanted to create redness in an area like your face, what are you going to do? If I want to make my face red, I'm going to go for a run. And when I go for a run, like I'm going to get hot and my face is going to get red. Why? Because, and my face gets hot. It gets red and hot. And why? I know you can figure this out, and I hope you yelled it out loud and proud. Vasodilation, doggies. Inflammatory cytokines cause vasodilation at the site where they're being produced. So you have an invasion of a bad guy, inflammation results, and vasodilation is one of the things that these inflammatory cytokines causes. Vasodilation, yeah, causes redness because there's more blood in the area that you're vasodilating, and it causes heat because there's more blood in the area that you're vasodilating. The blood, your blood is hot. It should be about 98.6 and degrees Fahrenheit, and that, you notice that, right? When you have an inflamed body part, it's red and hot because of vasodilation. Why would vasodilation be something that we would do? Like, what's the benefit of vasodilation? Dude, it's going to bring in, I'm going to put a little star because it's going to bring in the white blood cells. And that, it's also going to provide the barrier. But do you agree that if we vasodilate, we're going to bring in more blood? If you bring in more blood to the area, then you're going to bring in more blood cells that are going to be helpful. Now, guess what else you do? How do we get the swelling and the pain? Well, let me tell you true. The next thing is that inflammatory cytokines cause leaky capillaries. So capillaries that normally are just not leaky suddenly are more leaky. Why? How? We just end up with more spaces in between the endothelial cells, and fluid and blood cells and proteins can all leak out of your leaky capillaries. So check this out. Our leaky capillaries are going to allow white blood cells to migrate into the tissue, out of the blood and into the tissue, and that process is called diapedesis. So they're going to leave the blood and enter the tissues and move around in those interstitial spaces to eat the bad guys, dump chemicals on the bad guys, find antigens and go show them to other people, and initiate a bigger immune response. And we'll see in this section all the kinds of things that our white blood cells can do. We had leaky capillaries. Oh, proteins can leak out. Proteins that normally are stuck inside. What could those proteins be? They could be antibodies. They could be cytokines. They could be other chemicals that are going to initiate more of a response. The antibodies are a big one. Dude, those guys are like immune flags. They flag down people to say, hey, come in here. Here's a bad guy. I've attached to it. What's one of the consequences of losing proteins out of your blood? Dude, sad story. What happens to osmotic pressure in your blood? Osmotic pressure goes down. Do you agree with that? Because you just dumped a whole bunch of proteins into your tissues. So it's no longer, those proteins are no longer in your blood. If you decrease the osmotic pressure, which is pulling the fluid back into the bloodstream, you're actually going to get what? Swelling. Huh, how cool is that? The swelling that happens because of the proteins moving out and the water following those proteins out, that swelling leads to pain. And that's why you have the experience of pain when you have an inflamed something. Okay, so we had the diapedesis happening. Something that's interesting is that when molecules, when white blood cells squeeze out of the bloodstream and head into the tissues, that process is called diapedesis. They actually are following, they can be following molecules called chemotaxins. And you can think of chemotaxins as like a little, like breadcrumb trail. So the damage often will, like all the cells that were in the path of the damage are all producing their cytokines, and the white blood cells can be triggered. They're allowed to experience diapedesis and get into the tissues because of the leaky capillaries, but then how do they know where to go? They follow the chemicals to the site of the bad guys, and that's called chemotaxis. Chemotaxis is following those chemotaxins, which are the chemicals that'll get us there. Okay, I think that's everything in inflammation land. The next thing I want to look at is fever, because I said very clearly that the heat generated in inflammation is not the same thing as a fever.